fourth type here, we are going to be dealing with things that are either going to be growing in this way or things that are decaying this way. So you can kind of look at the equations. This type is called exponential, right? So we have exponential functions, which are functions. These ones are always growing or always decaying. It's actually an example of what we call a one-to-one function. We'll deal with word problems later this year. They're usually written in this form right here, a times b to the x, where a is kind of like an initial amount of something, but b is really dictating whether or not it's going to be growing or decaying, right? So obviously if you have 2 to the power of x, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. But if you had 4 to the power of x, it would be growing at a much faster rate, right? 4 to the power of 3 is 64. It's off the graph. Now, if you're thinking, how does a graph get smaller and smaller and smaller when you keep multiplying a number by itself? Well, if that number is a fraction between 0 and 1, like 1/2, the more you multiply by 1/2, it's going to get smaller and smaller and smaller. So like, 1/2 to the first power is just 1/2, but to the second power is a fourth, to the third power is, an eighth, to the fourth power is 1/16. So that's how numbers can decay or get smaller and smaller and smaller. What's interesting here, right, you kind of notice they all have the same y-intercept because b to the 0 is going to be 1. So a in all of these is 1. So you get the same y-intercept. The graph can go left. It doesn't show the quadrant over here, quadrant 2, but it can go left. It does show it a little bit over here. But what you always see is another example of what we call a horizontal asymptote, right? So you have this imaginary line that the graph will not cross under. It's not going to go below the x-axis. Because if you think about it, even if you had 1/2 to the millionth power, it's still not going to be a negative output. It's going to be something that's really, really close to 0, but never actually going to get there. So on your own, you can draw an exponential growth or an exponential decay, give it a domain and range, and move on to the next one.